directe,
proximité directe.
centrale.
Donc, tout ce qui peut être fait pour récupérer la chaleur fatale dans tous les domaines, je veux dire, pas qu'avec le nucléaire, partout la chaleur fatale, il faut qu'on la récupère, ça peut être c'est une solution, mais ça relève de la technique du nucléaire, si on peut le faire, tant mieux, bien évidemment. Comme de récupérer la chaleur aussi des data centers. Hein.
Oui, oui, bien sûr, bien sûr. Qui est peut-être moins intensif quand même.
Moins intensif quand même, enfin, j'espère.
Merci, donc finalement une vision un peu, pas décourageante, mais un peu pas très bonne de ce qui s'est passé jusqu'à présent, en tous les cas.
Je veux dire, non, au contraire, on veut le réussir, la seule chose que si on veut le réussir, il faut qu'on se mette les vrais chiffres sur la table, il faut qu'on regarde comment on fait pour y arriver. Et le problème, c'est qu'il n'y a aucune critique dans ce que je dis sur les choix qui ont été faits par tous les gouvernements successifs. Je veux dire, la fin du mois, c'est avant la fin du monde. Je veux dire, il y a des arbitrages budgétaires à faire.
Ok, en continuant sur ces histoires notamment de réseaux de chaleur, Rolly, vous avez proposé, me semble-t-il, de remplacer une partie des centrales à tourbe, charbon et gaz de Finlande, qui produisent de la chaleur, par des petits réacteurs, par des small modular reactors. Est-ce que vous pouvez nous en dire plus dans cette direction? Est-ce que vous pensez que c'est... Enfin, bien sûr que vous pensez que c'est une option viable, mais est-ce que vous pouvez nous présenter un peu votre point de vue?
Thank you. Yes, please. It's working? Mic? No? Should I press a button? Ah, no, it's working. Great.
Micro.
Yeah, I have the... No, it's good. I'm going to have my presentation here, and he's going to be my remote control. I just need to see my next slide. So, yeah, small correction. I have not proposed anything. I've just studied it a bit to get the numbers. There, a couple words about me, please. Another one. I'm a science writer. I started as writing some books on oil and resource scarcity, and then moved on to climate and energy and nuclear in general. I'm also, next one, okay, yeah. I'm also an activist. This is what part of the role I'm here in. I co-founded the Eco-Modernist Society of Finland, which is an evidence-based environmental organization, which means that we like nuclear also a lot, among the other clean energy sources. And I also co-founded and now lead a think tank called Think Atom. Couple of words about that. It's a non-profit, independent think tank and consultancy. In a nutshell, we try to study and popularize how to decarbonize different sectors of the economy with nuclear. And there was some of our recent work. And I'm gonna talk about the middle one, which was the nuclear district heating in Finland, which you can actually get a paper copy of as long as they last on the table outside. So, district heating energy sources in Finland are about half based on fossil fuels currently. Then there's wood and industry waste streams and waste heat as well. I'm going to talk a little bit about the study next. This is the structure. So we look at the Finnish district heating networks. We look at some of the small reactors that are being developed around the world. We combine them in a simple model on a monthly demand basis, and then look at the emissions reduction potential and discuss a little bit about the business cases, how you could operate a fleet of very small reactors, for example, because probably not every utility wants to be a nuclear operator. There's a lot of this kind of overhead and regulation that's going to be very expensive if you're just operating a couple 10 megawatts of nuclear. And then we discuss some of the licensing regulation and public discussion. Things there. So that's the first part, the distribution of Finnish district heating networks by annual demand. And mainly we look at the bigger ones, the largest 40 of them, which have a combined consumption of about 30 terawatt hours per year. Next. And then the reactors, we look at heat only as the main thing. So maybe a reactor that only produces about 100 degrees hot water, so there's no turbines, there's no pressure, there's very simple stuff. Then we also have light water reactors that we look in with combined heat and power, so you can generate electricity but also generate heating for the district heat. And then we look at some of the advanced nuclear reactors that are being discussed and designed around the world. Good. Then on to the modeling. The district heating network sizes that we looked at are, well, you can see them 200, 500, 1500, 2400 and 7000 gigawatt hours per year sizes. And then we also have this case study on Poland, which might be of interest to the Polish colleague here. We look at two sizes of networks. And these are the reactor sizes that we are using to connect those networks. That's thermal capacity, not electrical. Like I said, we look at mainly at heating things. Also discuss a little bit of district cooling and like I said, combined heat and power. Okay, let's get to some of the modeling results. This is the smallest one that we looked at. It's a small 24 megawatt thermal reactor. That's basically a research reactor, maybe a bit oversized, but still. And we put it into a 200 gigawatt hour district heating system. And that's you can see the annual demand variation in the blue. So we can actually have 5 times more demand in the winter peak than we have in the summer low. And with one such reactor, you could run it at roughly 80% load factor and produce 3/4 of the total demand. And we have in Finland about 20 of these kinds of systems. Then the slightly bigger one, we have 2 of these reactors in a 500 gigawatt hour network, producing even more energy. Now you can time a little bit. The annual maintenance is 1 month, so either July or August. You can have one operating and running the other one and then switch. So decent load factor, 70% of the energy produced in a carbon neutral way. We have about a dozen of these kind of systems in Finland. Then to my hometown size, which is about 1.5 terawatt hours, yeah. We have 5 of these in Finland. And now we bought 5 of these small tiny reactors there, and they're producing almost all of the heat. No, 2/3 of the heat and running at pretty high, almost optimal load factor because you can time the maintenance nicely. It's more reactors. Then a step up into 2.4 terawatt hour networks. It's Espoo, Turku at least. We have 3 cities of that size here in Finland. And here there's an example of combined heat and power. So the gray column is electricity production, which we can put up or down depending on the demand for heat. So heat comes first, and then you do electricity with the rest. And well, there's 3 200 megawatt hour combined heat and power reactors in this system, and they basically take care of the whole heating thing. And then we look at finally at Helsinki. So 7 terawatt hours. I have here combined heat and power as well. 8 of those. Still small reactors. I mean, they're only 200 megawatts. Thermal. It's basically the NuScale, if you have heard about the NuScale reactor that they're developing in the United States. So this is that size. So you could produce almost all of the heat and quite a lot of the electricity as well. So some of the key findings. Roughly half of the district heating, which is the half that uses fossil fuels, could be supplied with heat-only reactors. So you wouldn't have to do combined heat and power. And you could run them at high capacity factor, which would mean quite low costs. And there's a market of about 5 to 8 of these slightly bigger reactors, and then maybe 20 to 30 of the tiny ones in the biggest towns. We could decrease our emissions by about 5 million tons CO2 per year, which is the emissions from fossil fuels today from the district heating network. And we would have no pressure to increase the use of bioenergy. If we do combined heat and power or allow for a little bit lower capacity factor for the heat-only reactors, then we could do maybe 70%. So the very small district heating networks, there's no case for them because they're so small. It doesn't matter that much. But in this scenario, we would also have forest residue left for more valuable uses than burning. Levelized cost of heat estimates are, well, it's a large range, but 15 to 30 euros per megawatt hour, depending on load factor, depending on how expensive or cheap we want to make building nuclear here in Finland in the future. But basically, it would lower the cost of district heating from today and lower the emissions close to zero. And the key bottleneck is the lack of suitable regulation and legislation, which we are now working on, not the technology availability as such. I know that you cannot go to a store and buy a small reactor today, but by the time that you have the regulation and legislation done, I think you can. So let's go quite fast. The next one, there's some newness, a little bit discussions on the policy here in Finland. So public acceptance. This is the latest data from last spring. All the voters of different parties answered if they are for nuclear or against nuclear. There's two significant things here at least. The overall picture is that we've never had this good results as this one. And the second of note is that there is no single party that has more opposition than proposition. That's very encouraging, especially for the left and the Green Party. I'm really proud of them. They're finally embracing nuclear as one of the tools for climate mitigation as well. So new nuclear is progressing. A year and a half ago, we had a city council that passed the vote. That's the voting chart. So it was quite well passed to investigate a non-bioenergy option for district heating in Helsinki. And everybody knows that that includes also nuclear. And in a couple months ago, the government announced that they used to have carbon neutral by 2045, but they kind of subtracted 10 years, so that's 2035. It's pretty ambitious, I'd say. They're now planning how to do that. I would love to help. And just a couple of weeks ago, we had a parliament initiative to renew our regulation legislation to better allow the use of small reactors here in Finland for different uses, not just power, but also for industrial heat and district heating and such. And well, there's the actual leader of this working group in the room. She gave the welcoming speech, but there has now been started also a working group to see about the reforming of the nuclear legislation. And that's my slide set. Thank you for listening.